Okay, class, so let us now have the example number 7. Okay, in this problem, we are given here the viscosity of water. Okay, so take note, we are given water and the viscosity is 1.008 cp. The cp here represents your centipoises. Okay, so in this problem, class, take note, we have two unknowns rather. We are asked to solve for the letter A, absolute viscosity in pound-second per square foot. In pound-second per square foot. Take note, class, that viscosity and absolute viscosity are just the same. Okay? But this centipoise, or the common unit is poise, is another unit. But our standard unit is the pound-second per square foot. They are both in British engineering. But like I said, poise is another unit. And we may be converted it from centipoise to this unit here. So that is one of our unknown. For letter B, we are asked to solve for the kinematic viscosity. And it should be in the unit. What's the unit here? It should be in feet or square foot per second. And take note, in order to solve for the kinematic viscosity, we have given here specific gravity, which is equal to 0.998. Okay, 0.998. Now, how are we going to solve for this, class? Okay, now, I haven't included this in your lecture, but 1 poise, class, is equivalent to, this for letter A, to dyne second per square centimeters. Okay, so as you can see, dyne is a unit of mass. The same with pound. Square centimeter is in area there. So we have to convert here from dyne into pound and square foot into centimeter. The other way around. We have to convert from dyne to pound and square centimeter into square foot. Okay, that's our target. So what do we have, or what conversion do we have here? Now, we knew that 1 meter, okay, is how many feet? There are 3.28 feet. Okay, and how about dyne? Do we have conversion from dyne into pound? If you are familiar, class, 1 pound, I guess in physics we have this value. Pound is 444,800 dynes. Okay, that's the value. 1 pound is 444,800 dynes. Now, take note, class, that this value, dyne second, is equivalent to 1 poise. What we are after, or what unit do we have, is centipoise. This is centipoise. Take note of the prefix centi, which is equivalent to what? Centi means you have to divide it by 100. So this is a prefix equivalent to 10 raised to negative 2. Okay? Can you follow? So now, so that means, class, that once we converted already our or we have first to convert our 1.008 centipoise into poise, so that we could convert it here, and then we could convert it to this unit. Okay, so let us first convert this. So times, okay, so times, so 1 centipoise is equal to, or 1 cp is 10 raised to negative 2 poise. Can you follow? So they are just the same. So this is, or this is simply, all you have to do is divide it by 100. Your 1.008. Okay, so we have here, can you see it? 1.008 over 10, 100. That is 0.01, 0.01008. Or if you really want to have it, 1.008 times 10 raised to negative 2. There. We have, ayan, they are just the same. So the unit now is in poise. Okay? Now, since this poise is equal to dyne second over square centimeter, so this means that our unit here is 0.01008 dyne second per square centimeter. Can you follow? So this will be our working value. So from here, we'll be able to convert first. Let us first convert dyne into pound. Okay? So using this for conversion here, so we will put the dyne here, 444, 800 dynes in 1 pound. There, 1 pound. Okay? So that we could cancel out this dyne. Can you see it? I'm sorry. There. There. So we'll have, okay, isa-isahin lang natin na. So this is our absolute viscosity. So this value here, which is there, 0.01008, 0.01008 divide, we will divide it by 444,800. You follow? There. There. So how much? That is 2.266 times 10 negative 8. And what unit will be? Pound second per square centimeter now. Okay? Now, our target will be the square foot na lang. Okay? So, using the conversion from centimeter to meter, so we'll have it 100 centimeters is 1 meter. And then we will square it so that our unit can be cancelled out. Can you follow? So this will be cancelled and then cancelled. So you have to multiply your 2.266 times 10 raised to negative 8 into 100 squared. Okay, 100 squared. So this is, how much is that again? That is 2.266 there. Then you multiply it with 100 squared. So you'll have 2.266 times 10 negative 4. And the unit now is what? The unit now, class, is per square meter. Okay, but that's not our target. Our target is square foot. So using the conversion, 1 meter is equal to 3.28. Okay, so we'll have 1 meter is 3.28 feet. And we have to square it, of course, to cancel out the units there. There. So how much? So what you will do is this value, you will divide it by 3.28 squared. Okay, so this value, so I'll just put answer. I know. Again. I'll just encode it. 2.266 times 10 raised to negative 4. Okay, can you follow? So we will divide this by 3.28 squared. Okay? And the answer is 2.10. How much? 6 times 10 negative 5. There. Can you see it? And the unit now is pound second per square foot. And class, this is already our answer for letter A, where we have expressed our viscosity or absolute viscosity from centipoise into pound second per square foot. Okay? So here it is. Kindly screenshot. There. Okay, so now for the letter B, our target is for the kinematic viscosity. Okay, let me erase this first. The kinematic viscosity is solved by dividing your absolute viscosity by your density. Okay, but you don't have, or we don't have, the density. But take note, this is water. Okay, we have the value of your density of water, but take note, class, that the temperature here is at 68 °F. See, 68 °F. So the value that we had, if you could recall, on page, kindly check on page 3, kindly check, class. We have here a value of density, which is, we have the 1.94 slugs per cubic foot. But take note that this value, class, is at 4 degrees Celsius only. Okay? So therefore, we cannot use this constant value of the water, which is the density, here in this problem. Okay? But take note that in letter B, we are given the specific gravity. Okay? Specific gravity. Which, if you could recall, specific gravity is what? Specific gravity is equal to, or can be solved by density divided by the specific density of water there, or you can solve it by using the specific weight of the substance and then specific weight of water, or you can use the weight itself. Okay, so in this case, we will just use this part right here. Okay, so since they are just the same substance, which is water, but like I've said, our reference, which is this one, which is, how much is it again? It is, if we checked, that is, how much? In your lecture, that is 1.94. Okay, 1.94, but here at 4 degrees Celsius siya. So we are trying to solve for the value here. Okay, so what we will do is we will multiply it. So as you can see, specific gravity times your density, which is 1.94, or your density of water. Okay, so substituting, we have 0.998 times, no, take note, there's no unit, 1.94 slugs per cubic foot. Okay, so what will be the density here? So this will become 0.998 times 1.94. So we have 1.93612. Okay, 1.3692. And that is the value that we will be substituting here in our formula. So I will... Okay, so like you said, this value here, class, of density, we will be substituting it to this formula here to solve for the kinematic viscosity. So I have rewritten the value of your absolute viscosity earlier, which is 2.106 times 10 raised to negative 5. So using the formula, absolute viscosity divide your density. Okay, so I'll substitute it. We have 2.106 10 negative 5 pound-second per square foot divided by your density, which is 1.93612 slugs per cubic foot. Okay, let us first let us first evaluate the values class, the 2.106. 2.106 times 10 raised to negative 5 there, and then divide by 1.93612 there. Can you see it? There. So you'll have the value 1.088 and times 10 negative 5. But the question, class, is what is the unit? Okay. Now, if you could recall in your lecture that is on page that is page 2, yeah, slug is equivalent to pound second squared over feet. Okay, now looking at the units here, we can simplify this as let us take this first. So pound second square foot times, so since we have here a fraction, so we will get its reciprocal, so cubic foot over slugs. Okay, so from here, since one slug is pound second squared over foot, okay, so we will introduce second here in the let's see, let's introduce second here. Wait, let us na lang, cancel this one. So this will become pound second foot over. Okay, so this will become, okay, so we will cancel this one. So the unit will become pound second dot foot over your slugs. Okay, but your slugs is equivalent to this one, pound second squared over foot. Okay, so what will be cancelled out, class? We can cancel out this pound second and then here and this one. Can you follow? So only one S rather there. So what will happen? You'll have feet per second per foot there. So from that, feet times the reciprocal of this, feet over second, or that is equivalent to square foot over second. So this will be, class, the unit of your kinematic viscosity there. Okay, so as you can see, this is our answer for this letter B, which is your kinematic viscosity should be in square foot per second. Okay, kindly screenshot.